This is David Wong, and I noticed that CTF on smart contract the other day, and I thought that was a lot of fun, and I thought I could do some sort of walkthrough through the CTF and kind of show you how I solve this thing and how much fun it is, and of course I encourage you to do it yourself and to try to solve the challenges yourselves. Uh, but if you just want to watch me do it and just learn from that, that's also a possibility. So this is this was a CTF for DEF CON, I believe. This is an ongoing CTF. It's over, but you can still play it. But there are many write-ups. The first two players who so you have a high score here, and it shows you everybody who wins by order. So this is the first players who won because they won in this block here. Um, and I think the first two players published write-ups themselves. So I'm not spoiling the game for anyone. There are already a bunch of write-ups. So yeah, what is this thing? Well, it's a smart contract CTF, and it kind of runs on your browser. Really, you don't need much to play it. You just need MetaMask, which is a plugin for Chrome. It's here. Um, it's kind of a wallet inside Chrome. It's not a real node. You don't have to sync up to the real network, so you don't have to uh, download and verify the blockchain for hours or for days. It's kind of doing that for you on a different server. And here we play on the Robson test network, so we don't really play with real money. It's just fake money. So no worries. And see, everything when you want to interact with the game, everything can be done in the browser's console. So I can hit Option, Command, and J, opens the console, and I have these nice messages, plenty of colors, and some helper functions. Everything is really well made. That was really a real pleasure to go through that CTF. So here, for example, they tell me if I want to get the address of the player, which is myself, I can just type player, which is kind of a shortcut for the address of my wallet here. Um, use the console helpers, blah blah blah. This level is not really a real level. It just kind of teaches you how to use the game, and so I'm not going to finish it because it's not really interesting. What I'm going to do is I'm going to go directly on the fallback level, and on every level I have to launch my instance. I think this runs a contract, this deploys a contract, and so I have to run a transaction via MetaMask. So this thing pops up, asks me to pay a few USD, and this is not real money. Of course, we're on a test network, and I cannot really do it. It tells me insufficient balance for transaction because I don't have Ethers yet, right? This is a new test account that I created for that CTF. It's called Ethernaut CTF, and I don't have any Ethers. I have 0 Ether. So what I can do is I can click on this Buy Ether button, and since this is a test network, there is this thing where I can request Ether. And it's for free. And I can go here and I can just wait. Um, so I need to wait for a miner to find a block, to mine a block, and to propagate it on the blockchain to mine my to integrate my transaction. So here that would be the transaction of 1 Ether to my contract. So it can take some time, right? We really need to wait for someone to mine. That's actually what's going on, even if it's a test network. And yeah, all right, I got it. And so sometimes you will see every time I need to do some interactions, it will take some time. So here, let's just request a bunch of ethers. Like that, we make sure that we have enough. And so every time I want to deploy this, I will have to click it here first, and this will deploy a contract only for me. Well, it's on the network, but I can interact with it, and like that, nobody can modify it while I'm doing this. So, whoop, here I did it twice. So the first I send a transaction the first time. Here I got another one. I'm just gonna reject it because I clicked twice on this button, right? So now I basically just have to wait for the contract to be deployed. What is this level? What do I have to do? I have some source code here and I have some indications here. I need to claim ownership of the contract, and you're going to see what it means, and I need to reduce its balance to 0. So contracts are addresses like wallets, like real accounts, and so they can have money, you can send them money, they can send you money, and they have a balance. So here's the source, and we'll see what they mean by you claim ownership of the contract. There is an import here, and let me pause for a moment, but the transaction just got mined, so we have an instance here. That's the contract we're gonna play with. I can play with it with contract here, and for example, if I want the address, I can write that, and we notice that it's the same address. All right, let's go back to our contract. So there is an import here uh, of a different contract. So this is all written in Solidity, so the extension is always .sol. You have the version of the compiler that is being used here. This means that it's greater or equal to this version of the compiler. And here my contract is called Fallback, and it's an extension of the ownable contract that we have here. So Zeppelin is this organization, and they have a bunch of contracts that you can use. They're very short, for example, the ownable contract here, and they can extend your own contract. So you don't have to rewrite code every time you want to deploy new contracts. So what is ownable? Basically, it's a very simple contract here that we can see on their GitHub page. A contract called ownable has a field which is an address, and it's public, called owner, and it has a bunch of functions. We don't care about these events. This is really to log or to have hooks on different applications, but it has different functions. And really, the function that is interesting here is this ownable constructor, right? It's the same name of the contract, so it's called when you deploy the contract. And what it does is that it sets this owner variable to you, the message sender. So the person who deployed the contract becomes the owner. So here, basically, when you look at the different functions we have in this contract, you can see that sometimes you have a modifier called only owner, and basically only the owner of that contract can use that function. And so when you extend a contract like that, basically what it does is that it copies every function and every field you have in this ownable contract here over in this fallback contract. So you can imagine fallback having this ownable public variable here. And when something is public, you always get a getter function for free. So I can just do my contract owner, so owner, which is this function here, this variable here. But so I have a getter for free, and I get a promise because we do things over the network, and I can read that promise, and yep, this is the owner of the contract. And you notice that this is not my address, it's a different address. And this is because when I deploy that contract, probably I just call another contract that will deploy this contract. And so the contract I call when I click on get new instance will be the owner of this contract. So I haven't looked at how it works, but this is what I imagine is being done under the behind the curtains. All right, so we have this contract, and we know that there is an owner that is not us, and the owner can call some functions. Only the owner can call these functions, right? So what we want to become the owner. That's the goal. So we look a bit around, and we see two different functions that allow us to become the owner. There is this contribute function, right? Owner equal message sender, which is us if we call that function, and there is this function which doesn't have any name because it's a callback function. And here we can see it sets the owner as the message sender as well. So that could be our first way to beat the level. So let's look at the first function. It requires that your message value is smaller than some number of ethers, right? So you can send money to this function when you call it because it's payable. and you cannot send too much of it. Otherwise, it throws and it just reverses everything that was done and it just cancels the execution of that function. And then here we have the contributions. So contributions here, you can see that it's a mapping from addresses to a number, and it's public. And basically, we can guess that it's just a kind of database of how much money or how much tokens internal to this contract are attributed to every address. So in the beginning, you wouldn't have anybody, nobody would own any tokens, but as you give tokens to people, you would add them in this dictionary, this this dictionary of addresses associated to amounts of tokens. And here we are looking at our number of tokens, and it has to be greater than the amount of tokens that the owner has. Okay, so that might be possible, and we can actually very easily take the address of the owner and use this public variable so that it has a getter, right? So we can take a contract, contributions, and as argument, we give it the address of the owner. And we have a promise, but it's very fast because we're just doing a call, so we don't really change any states. So we don't have to send transactions. This is instantaneous, and we get the amount of token that the owner has. So that's a large amount. Maybe we can get this number of tokens. Okay, so that might be another way, to become the owner, to execute this part of the code. Let's look at the other way here. If we call this callback function, so how do we call a callback function? Just by sending money to the contract, it will work because this callback function is payable. We execute this function, or if we call a function that is not in the contract, if we make a mistake, for example, the callback function will be called. So anyway, what does it do? It's payable, we can send it money, and actually it requires that we send it money. If the message value, if the money we send in our transaction is not greater than 0, it doesn't work. So we have to send money to this function. And our contribution needs to be greater than 0. So here, again, if we look at our contribution, we'll see that contribution of player, we'll see that it is, oh, we have a bug here. Oh, it doesn't work. All right, that works. We can see that it's 0. So we need a contribution before we can run this code. Otherwise, it's not gonna pass this require. So how do we contribute? So yeah, we need to use this contribution function, right? Contribute function. It doesn't matter if we don't become the owner here, we'll still get some contribution, and the number of token we get here is really the number of ether we send, or rather the smallest unit, the number of way. So okay, let's try that. So how can we do that? We can call the contract function, contribute function from the contract, and it doesn't have any argument. And then we pass the object, which is the set of option we want to send, to have in our transaction, and we want to send some money. So here we'll just send one way, which is the smallest unit we can send. Usually when a function has arguments, you will write the argument, and then at the very end you add the last argument, which is this object, but here we don't have any arguments, so we can just write the object as the first argument. Also, sometimes you can say it's from a different person, from player, but here it will know that it's from player because we only have one account, or to something, but here it knows that it's the contract we're calling because we have it here. Anyway, that should work. We're just calling this contribute function with some value which is way smaller than this amount of ether, so it should be fine. And here we're sending a real transaction, so we have this thing popping up from MetaMask, and we have enough ethers to send it, so we'll submit it. So that transaction is going to be sent. It's going to take some time to get mined, and you have to get used to that. And now we'll look at how much we have. So I'm gonna use the getter of contributions, There is also this function called get contribution that we can use. For example, it's exactly the same, except that it only gives us our contribution. It doesn't take any argument, and it gives us only our contributions for our index, our address. It's not like this public getter that we get from this. So let's try it. Whoop. This transaction got mined, by the way, so this should work. We should have one token. Whoop. So let's try this. And here, yeah, we have one token. So we have money. So now we should be able to call that callback function because the message, I'm sorry, the contribution we have made is greater than 0. And we still need to send money to this function to pass this require. All right, how do we do that? Well, we can just send transaction. This is a great function to do that. And let's do value equals 1. And that's it, right? We shouldn't need more than that. We're sending some money here. All right. Gonna have to wait a bit again. And actually, while I'm waiting, um, let's look a bit at the rest. Here you can see the name of the contract is called Fallback. So the constructor is also Fallback. So this gets called without arguments apparently when you deploy the contract the first time, and apparently the the guy who's deploying the contract, or the girl who's deploying the contract, gets 1,000 ether to begin with. All right, we mine the transaction. So now we should be the owner. Let's try to confirm that. Um, and that's our address, remember? Whoops. And yeah, we are now the owner. Great. So we did the first part of this challenge. Now we have to reduce its balance to 0. So there should be a function to do that, maybe. Yeah, we can withdraw. And when we withdraw, it's only for owners, right? But we are an owner, so we can call that function. And when we withdraw, what happens? Well, we will transfer the entire balance of this contract to the owner, which is us. All right, let's try this again. Oops, sorry. Withdraw. That's a transaction, right? And we just have to wait for it to work. So in the meantime, I'm gonna go on the other things and I'm gonna get new instances for all the next challenges. Like that, I'm not gonna have to wait every time to get a new instance. Whoops. All right. So now let's go back to Fallback here. And I just want to see if it worked. In the meantime, I'm just gonna get, okay, I have this function, I think get balance, yeah, get balance of the contract address. And if it's equal to 0, we succeeded. It's equal to 0. All right, so now we can just submit this instance. And when we submit it, we have to call the main contract of Ethernaut, which takes care of who did what challenge and takes care of the high scores and everything. So we need to send a transaction. So it's pretty cool. Even the CTF runs on the smart contract. All right, I submitted that, so it will take some time until I get a confirmation that I indeed successfully finished or solved that challenge. All right. In the meantime, let's go to Fallout. So claim ownership of the contract below to complete this level. So same problem as before, except we don't have to empty the address, the contract. We just have to become the owner. And here you can see the contracts code again. And here we have this ownable.sol that gets imported, and our contract is ownable. So same construction. You can see here in the console that they have received our submission of the fallback here. We have a nice check mark and a funny message, colorful message that we have completed the level. All right, let's look at this contract. And same thing as before, I'm going to look what function allows me to become the owner. So this first function here allows me to become the owner, but that's the constructor, right? So no, it doesn't work. And I look at everything else, and there is nothing really that allows me to become the owner. Now, if I come back here, um, there's something weird with the constructor. And you might not have noticed that, and maybe there's an easier way to notice it. If we look at the contract ABI, we can see that the constructor is in the list of functions we can call. And this is not normal because there should be no constructor in here. The constructor is only for deployment. But here it might be easier to read. The constructor's name is different. It's fall one out, whereas here it's full out. So either it's a typo or this contract was renamed and they forgot to rename the constructor. But basically, no constructor was called during the deployment of the contract. Instead, we have this public function that is payable. We can send money to it, but it doesn't matter here. We don't need to. That anybody can call, and actually anybody can become the owner thanks to this function. So let's just do that. Oops. And we're sending that with some gas so that the miner can run this transaction. And this should work. So really, we didn't even look at the other functions: allocate, send allocation, collect allocations, allocator balance. This is kind of a known bug, this constructor problem, and actually the first time I was looking at the CTF, it just I was looking at this function, I just saw that it was one here. But yeah, depending on your font, you might not see that correctly, and it might be harder to see. And actually, during this CTF, I was writing contracts, and I did the same mistake. I changed the name of the contract, and I forgot to change the name of the constructor, and I didn't understand why it wasn't working. So this is definitely a common mistake, and that's something that can happen to anyone. All right, so let's check if we're the owner. That's our address, right? And indeed, we are the owner, so we can submit that. And that was an easy challenge. All right, let's go to the next one while this takes over. All right, so the goal of this level is for you to hack the basic token contract bill. You are given 20 tokens to start with, and you will beat the level if you somehow manage to get your hands on any additional tokens, preferably a very large amount of tokens. So okay, you start with 20 tokens. So again, contract that is called token. It has an internal uh, token system, and you want to get more tokens. And you have a hint, you might have a way of getting a large amount of tokens. So let's look at the contract. And by the way, looks like I got the Fallout challenge. So here we can see that we don't have a way to donate an amount of money that could be translated to token in that system, right? We don't have any contribute or donate function or any of that. Besides the constructor, we only have transfer and balance off. And balance off is a constant function, so you don't need to run a transaction to call it. I can show you actually contract balance of player. Yep. And it returns directly. And we have indeed 20 tokens, right? So it returns the amount of token that owner owns. And here you can guess balances is a mapping of addresses to unsigned integers. Again, this is very common. This structure is very common. Now we can transfer some ethers to a different address. All right, cool. Uh, we can decide what address we transfer it to and what amount we transfer it for. I'm just reading the signatures, the definition here, the declaration, and I can understand that because it's clear. But looking at the code, we have a confirmation. It just reduces our balance of that amount and adds that to the balance of this destination. Now, if we look at the require, and this is something again, this is like a known problem or kind of problem in Ethereum. You deal with these unsigned integer, and here when you want to check for sure that something minus something else is greater or equal than 0, it's not gonna work because unsigned integer don't have a sign. That means that they're always positive or equal to 0. So this will always be true. So whatever we do here, this require will always be true. That means that we can always send money, basically, as long as we have some tokens to start with. So here, what I'm gonna do is that I'm gonna try to find an address that I can send money to, and I don't really care about that address. I really care about my amounts being subtracted. So first I'm going to go in high scores, and I'm going to be very nice to, well, this is taking some time. I'm going to be very nice to that first player, and I'm going to send him some money. All right, so I'm gonna call the contract function transfer to this address, and I'm going to send how many? Well, you can guess if I send 20 tokens, then I lose all my tokens. If I send less, then the function works correctly, but what if I send more? Actually, what if I send exactly one more, so 20 plus 1, to this uh, function, to this person? Well, what happens is that this is going to work because it's always going to be a positive number, right? It's going to wrap around, and this is going to wrap around as well. So my amount of token, which is 20, minus 21 is going to be what? It's going to be the maximum value you can store in a uint. And maximum value you can store in uint is, well, a uint is an alias for uint 256. So the maximum value is 2 to the 256 minus 1, I think, or something like that. Anyway, that's just the maximum value you can hold in 256 bits. So what I will do, I will check my balance now that I did that. Whoop. Balance of the player. But we need to wait for that transaction to pass, right? Otherwise, it's not going to work. This is taking quite some time here. All right, mine transaction, so we can call that. And here is the result. So that's the amount of token we have. The amount is so large that it's split into several segments. Okay, so we did what we had to do, right? We managed to get our hands in more tokens, and that's actually a pretty large amount. So let's submit these contracts, and we basically solved that. That's about it. So let's look at the next one. The goal of this level is for you to claim ownership. All right, ownership again. Except here, we're not importing anything. We're not extending any contracts. All right, I'm done with this one. So let's go back to this one. I'm not extending any contract. We have the owner variable directly in this contract. And here we use the constructor to set the owner of this contract to the argument of the constructor. And here we have a poon function that sets the owner to the message sender. All right. So actually, when we look at this, we now have two contracts. We don't have one contract, we have two contracts. And here in this second contract, I'm using a field of type delegate, which is the first contract. That means that this variable here is really an address, but it's an address pointing to something that is a contract delegate, which is something like this. And we can see here it has two functions. It has a fallback function, it has a constructor, and the constructor takes an address, And what it does is that it sets the owner. So same thing here, we have an owner to the message sender, the person who deploys that contract. And it also sets this delegate contract address to what we gave it. So you can think of that as kind of a library or something like that we want to interact with, and we set its address during the construction of that contract. So here, what do they mean when they say claim ownership of the contract? Do they mean this contract or this contract? And actually, when we type contract something or contract address, is this the address of this contract or is this the address of this contract? So here, usually when you have two contracts, you will usually deploy this one, and this one serves as a reference so that you can write delegate here to mean that you want to use this contract here with these functions. Like that, you can call them directly and you don't make any mistakes. You cannot make mistakes. So to make sure of that though, I can look at the ABI of my contract, and I can see that I have owner. So this is basically the getter that is created because this is public, or this is public. So it doesn't really tell us anything, any good information. But also have a constructor and a fallback. All right. So we look at this one, it doesn't have a fallback, it has a constructor, and this one has a constructor and it has a fallback. So we're really looking at this contract here. And here we see something interesting. We call the delegate contract, which will be this contract at some address that we've set here. And we call the delegate call function. And actually, that's not a function of that contract. This is a built-in function that you have for any contracts. And when you delegate a call, it's basically a call that you're making on that contract here. But you're telling that contract, you're giving that contract some trust. You're trusting them to do whatever they want with your data here. So basically, if you delegate call some functions here in this contract, and it does something like owner equal message sender, it will not change the owner of that contract, but it will change the owner of this contract. And it will not take message sender equals this contract, the address of that contract that is calling this one, but rather the address of the person calling this contract. So any variable here that is called here is not what this contract sees, but really what this contract, or rather what this function sees. So for this function, what is the message sender and what is the owner? Well, the owner is here, and the message sender is the person executing this contract. So really, if we look at that, we cannot change the owner via the constructor because we cannot call it again. But we might be able to change it by doing something with this call here. So this is calling something, and whatever we want to call actually, because we control that on this contract. And here we can only call this spawn function, and it's actually good because this is the only function we want to call. It does exactly what we want to do. It sets the owner as us. So let's do that. Let's try that. And let's see if I can remember the syntax. So we called our contracts, and here we want to call the fallback, so we'll just send a transaction. We don't need to send any money, so we can just don't have anything, or we can set value to 0, it's the same. And here the data of our message will be the signature of this function. We want to call this function. So how does it work? Well, to have the signature of a function, you take the SHA-3 hash, and here we'll use Web3, which is an API that allows you to interact with your wallet. So if you have MetaMask, you have it, and it has this SHA-3 function, and we'll give it the string pound. It has no argument, and we hash this thing, and that's the signature of this function. And then we take the first 4 bytes, and this is an hexadecimal string because you have 0x here. So this is 1 byte, 2 bytes, 3 bytes, 4 bytes. Take the 4 first bytes of this, the hash of this function, and this is basically what we can call. So okay, let's do that again. Send transaction, and then in the data we write this, and this should basically work. That's it. It's going to see that data when it's going to make the delegate call, and that data is going to tell it what function to call. And it's going to call that pawn function. It's going to set the owner as us, even though it's in a different contract, but you understand what I explained previously. So let's call that. All right, we have to now wait until this transaction gets mined, but let's prepare ourselves. We will check after that we are the owner, and see if indeed it worked. Taking some time again. Um, in the meantime, I'm going to do the promotion of my blog, cryptology.net. I write a lot about crypto and about crypto in general, not just cryptocurrencies, you know. And yeah, if you're interested in stuff like that, or in crypto in general, or in security in general, uh, check my blog, and you'll see more about these kind of things. So this is taking some time to load. All right, I have internet. All right, so let's check if we're the owner. Undefined. All right, I have a bug here again. I think new versions of Chrome you can use the await keyword, but here I don't have that. Panning. Yeah, I have a very slow connection, so it's not helping. Um, so I might be able to do something with that. Hmm. All right, I got the answer here, and this is my address, right? So we should be able to submit that, and right on, and we're going to see if it works, but instead of waiting, we're just going to go to this one. All right, so some contracts will simply not take your money. All right, and the goal of this level is to make the balance of the contract greater than zero. All right, so I told you they can send money to contracts. They're basically addresses, like account addresses, and they have a balance. But here, apparently, this contract will be more problematic and will not be able to send it money. So why is that? Okay, so that's the code of the contract, and it's basically nothing. So uh, that's not very good. So, all right, we completed the previous level. So anyway, we look at this, and the first time I look at that, I was wondering if they just hid the code of the contract and we were supposed to kind of reverse it, engineering the contract ourselves. So the first thing I did was to look at the ABI of the contract, and here we have nothing, so it's kind of weird. The second thing I did was to get the to go on. So wait, what is our network again? Our test network, Robstan, all right? So robstan.etherscan.io. Etherscan is great if you want to check a blockchain or whatever happens on it. And we're going to take this contract address and check it on the blockchain, on this Etherscan thing. And we have no matching entries. This is weird. We're on Robstan, right? We have the contract address. So this should work. Oh, I guess there are no transactions, but there is the contract. It was created. So we can look at the contract code here. And yeah, if you're the contract creator, you can verify and publish it. And that's what people usually do. So you can check the contract code, and you can verify also that it's the one that matches the bytecode, the compiled contract on the blockchain. And here there is no source code, of course, nobody has done that. And we can see the bytecode here, and we can actually use a disassembler to see the opcodes, and we don't have much. And actually, this is just the code that you need for a very simple contract like that. So they didn't lie. This is actually completely empty. And if this doesn't have a fallback function that we can call and we can send money on it, exactly like this fallback function, like here, which has this payable keyword modifier, then we cannot send money to this contract. It will just refuse our money. Actually, I can try to send money to it. Value 1, for example. Um, and MetaMask should warn me, and yeah, they say approving this transaction is likely to fail. The message is not very indicative, verbose, but it tells me that it's probably going to fail. All right, so what can we do? Well, if you don't know what to do, well, you don't really have a solution here, but I'll tell you because this is kind of something that is known in Solidity, or not in Solidity, but in EVM, the Ethereum virtual machine in general, is that if you create your own contract and you have some balance on your contract, and then you kill your contract, then you can tell where the money that you have on your contract goes before it gets killed. And if you use this way of transferring money or ethers to from a contract to another one, then this contract cannot refuse the money because it cannot return it back to the contract that is getting killed. Not possible. So to deploy a contract, you have many ways, but the easiest way is to use Remix, which is a browser kind of thing to code your own contracts, but you can compile them. It has a static analyzer, a debugger, and you can run functions and deploy contracts. So here, just make sure you're using the injected Web3, so that it uses the MetaMask Web3, so you can deploy and play with your contract on a real network. But if you just want to play on your on a test network, you can use a JavaScript VM, and it creates a local network for you. So here I'm gonna write a contract. So I'm going back here. I'm gonna get this boilerplate. Whoop. And I'm gonna call it what? I call it attack, okay? And I have a constructor here. And my constructor will take some money, like that I can put money as soon as I deploy the contract. And I actually don't want to do anything else. I just want to put money on it. And then I will have a function that I can call to attack. Well, actually, this is, yeah, I can do that. I can call to attack, and this is a public function. And what it will do is that it will self-destroy. And I think this is the function, I'm not sure. It will self-destroy and it will send money to our contract here. So what's the address? All right, whoops, self-destroy and undeclared. Okay, this is not the correct function. So what is it? Self-destroy Solidity. Googling it. All right, suicide. I'm going to try suicide. Suicide kill maybe. Self-destruct. Yeah, that's the correct one. Um, I don't think this is destroy. All right, I'm not getting a quick answer here. Where is my quick win? More keywords. Suicide. All right, so maybe that could work. Suicide. Okay, it's been deprecated in favor of self-destruct. Isn't it what I used? All right, maybe I'm doing something wrong here. Oh, self-destruct. All right. And my argument is invalid because it's a string. Okay, so shouldn't be a string. Okay, that looks like it's going to work. I get a warning, but I'm just going to ignore that. I get a warning here, but I don't care also. That should work. And now here I'm going to deploy that contract, which is called attack here in my fire ballot. and I'm going to give it some initial value of one way. I don't really care. And I don't care what address I deploy it, I just create it. All right, so that should work. All right, it's creating the contracts. I'm going to take some time. And here, I'm going to prepare my function to check if it worked, which will be get balance and the contract address. So right now it is 0, but I want it to be 1, right? Still creating. Can take some time. Yeah, if the code is not given and you want to kind of reverse it, you also have decompilers. You have something called porosity that is quite good. So this is one of the way to reverse a contract. So you write porosity like this if you want to find it. All right, so this should have been done. Yeah, the transaction is done. Oh, we still need to call the attack thing, right? So here we have our contract that is deployed at this address, and we're gonna call the attack function. So now we have to wait again until this gets this transaction gets processed. So in the meantime, I guess we can start looking at reentrancy. So the goal of this level is to steal all the funds from the contract. So here you don't need to become an owner, you just need to steal everything from the contract. And here we have pretty simple contract here. We have a mapping of addresses to uint. So again, balances. This is a token system. Here you can donate. So you can create token by sending money to this function. It's payable. And you can say to who you're giving money to. Okay. You can get the balance of an address because actually this is public. So this is not really needed, right? But you have it. And you can withdraw money. And finally, there is a callback function that is payable just to send money to the contract, but this is not going to be useful for us. All right, let me just go back here. This is done. And so if we go back to force, this should give us, yeah, 1. So now we have money on this contract and we can submit this instance. And it should work. All right, that was fast. You have completed this level. Okay, reentrancy, the last one. So let's go back here. And okay, you can donate some money, and we'll start by doing this. So it's going to be, actually, we're not going to start by doing this because I'm going to have to write another contract. So I'm not going to do that. So let's look at the withdraw function. So it takes an amount, verifies that your balance is greater than the amount. Okay, so that's normal. You cannot withdraw more than what you have. Makes sense. And if this works, this is executed. This is just the value that you're giving as argument, so we don't really care if this works or not because this doesn't have any effects. What if this thing? This is a call to us, to our address, message sender, with some value. So basically, it's calling the fallback function and it's sending some money. It's a way to send money if you want. It's sending some money, exactly amount of money, and it doesn't have a gas limit. So it's going to call our fallback function, and if it executes a bunch of stuff, it's going to work because we have a lot of gas. We don't have really a limit of gas, so it won't be a problem. And after that, finally, we remove the amount of money that we withdrawn from our account on the contract. And this is kind of too little too late because here what happens is that we're executing, or there might be some code execution on the contract on the address that we're calling, where we're sending that amount of money. So if I do that with my address here, my wallet, nothing will happen, right? It's a real account, it will work. But if I give it the address of a contract, well, it's going to execute the fallback function of the contract. So we're going to create a contract. Same thing here. except that we'll have a fallback function, and we'll make it payable and public, so that when we use the contract to withdraw, actually I'm gonna start writing the code for that. Whoop whoop whoop. Here I'll call that address target equals this. I don't think it's a string. And here we don't self-destruct. Here we'll call these targets. I will make a call. Oops. And what we'll do is that we'll call this withdraw function. And when we'll call this withdraw function at this point, and we'll need some balance, right, to pass these tests. But at this point, when we'll actually withdraw the amount and when this contract will send the money to our contracts, this will execute our function and it will call withdraw again, right? Before this can be executed. And if this hasn't been executed, then this check will work, right? We still have the amount, we still have the money on our balance. So we can do that over and over and over, and kind of withdraw a large amount of money without this being called. So that's what I'm gonna do. All right, how do I do that? How do I call this thing by its signature? Well, in Solidity you have something called byte4 to take the SHA-3 hash of our function, which is withdraw unit amount here. And SHA-3 is not really SHA-3 in Solidity. It has the name has been changed to Ketchak 256, which is more accurate, but I'm not going to explain why. And here, when we create the signature of this function, we don't need the name of the argument, but we do need the full name of this type, which is uint 256. All right, so when we call this, when we call this fallback function, this should call the withdraw function of this contract, which will call this again and again and again, and we'll have some sort of loop, which we call reentrancy. So first I'm going to deploy this contract, okay? And I'm going to deploy it with some amount of money, just in case. I don't know why, but just in case. This I don't need it. Whoop. Okay. And now what I will do is that once I have this contract's address, I will donate some money via the donate function to this contract's address so that you can withdraw money from the other contract, right? You cannot withdraw if you don't have some money on the contract. So I have myself nothing, but let's do that. So contract donate and what address? So we don't have the address yet. Still hasn't been created. But we'll take a second argument, the object, saying that the value is 1. We'll say that we have one way. Okay, that's enough. And we'll donate it to the address, which is okay. So here I'm calling the fallback. Actually, I'm not calling it. I'm just clicking on that so I can get the address of our contract. And I'm rejecting this. I don't want to call it yet. Whoop! I donate some money to this contract, to my malicious contract. All right, and we're just going to verify that this works with the balance of thing. All right, so we're gonna wait until this transaction gets mined to verify that. By the way, the fix usually when you have this kind of things is to do the removal of the balance before you call any other contract. And also another thing, but when you want to send money to an address, usually you don't want to use low-level functions like call. You just want to use something like a transfer, which is a higher level function, and if it doesn't work, it will throw an exception. This is usually more safe. Okay, safer. So we have minor transaction. We can check how much we have, how much token we have on this malicious contract address. I mean, stored on this contract, and we have 1 token. So we can now withdraw by calling this fallback function. So now the trick is, and it took me some time to to make this work when I was playing the CTF, is that this reentrancy thing is going to consume a lot of gas. And if you don't give enough gas, because your gas limit is too low, then your reentrancy bug is not going to loop for efficiently. It's just going to stop because it's going to hit the gas limit. So here I'm just going to give it a big number to make it work. And hopefully this should work. So I will verify that on this side when it works. Again, what it should do is that it should send a large amount of money to my contracts. And so what it will do is that um, get balance of my malicious contract should be greater than 1, right? Because I gave it 1, but now it should have more. Okay, this works. So let's check that. Still 1. Okay, didn't seem like it worked. What about get balance contract balance of player? Oh, balance of, sorry, our contract here. How much is it? Still 1. So this did not work. My attack didn't work. So for some reason, I don't know why, but every time I try to play this part, it kind of gets stuck. So I'm gonna try one more time without making any change, and we'll see if it's some network because it's a test network or some issues like that. And if somebody watches this video and knows why this works sometimes or doesn't work sometimes, you can tell me. All right, so we're gonna run that transaction again just to verify I'm making things correctly. We're calling this withdraw function here. Yeah, withdraw here. Oh, all right. Okay, I forgot, but this withdraw function takes an argument, right? And here I need to give it an argument, so gonna give it 1. I want to withdraw one thing here. All right. So just because I changed that, I need to push it to a new address. So what's going to happen? So it's going to withdraw funds and it's going to re-enter multiple times here. And when these will have finished working, this will also reduce the amount I have on my balance. And so we'll have the exact same bug we had earlier, right? In the earlier contract when this thing just wraps up and we get the maximum amount uint 256 can hold. So I'm doing this, and at the same time, I'm getting a huge amount of tokens here for my contract, my wallet here, and I will be able to withdraw this with that function again. So to really empty every fund we have in this contract. All right, so let's get the same thing I did earlier, get the address of that contract, and send it some money. Contract donates, value equals 1. And see, this is kind of a cumbersome CTF because you have these wait times. Every time you want to try something, you have to wait for the network to mine the next block. And so it takes some time and it can be very tiring when you're stuck on something. and it doesn't work, and you just have to wait like something like 15 seconds or 20 seconds to wait for the transaction to be processed. All right, let's hope this time it works, increasing this limit. And here, maybe I just want this thing to run twice, to run once, right? Because wait, well, let me think. What am I saying? Maybe I just want it to run twice, right? Exactly, so that it's the maximum amount for this contract, the balance of this contract. And so I can maybe create a loop. I could have done a loop. So what? Small number unit 8 loops equals 0. I don't need to write equals 0. It's 0 by default. And here I could say if loop equals to 2, just return. And here I would just do loop plus equal 1. So the first time I call it, it adds a 1 here, equal the withdraw function. It comes back here, it adds a 2, equal the withdraw function a second time, and the third time it comes here, it just returns and it stops the loop. So here I would just execute this thing twice, and I would just get exactly the maximum amount. All right, so now let's see, get balance of this, please work. Still 1. Well, something obviously didn't work. Um, How about the contract balance of, okay, so yeah, so I haven't called, yeah, I'm not sure what happens, but this thing worked here. At least we have this amount here, um, that works. So, oh yeah, this is normal that it's 1 actually, right? Because we just withdrew our 1 token, so that this is fine. And here we had these things called multiple times until we run out of gas, basically. And here we have a huge number of token in our balance. So now we can use that to withdraw again, because this time we have a huge amount that we can withdraw. Actually, let's look